Okay, so hopefully we're live. So hello guys. Give me 1 second. Just want to make sure the stream is running the way that it should. Okay. So, okay, so let's go over here and all right, so welcome guys. So I wanted to make a live stream based on basically pre-calculus or college algebra, and I want to go over the algebraic method of what this stuff means and also some examples. I'm not going to really go over the graphic method in this video, or in this live stream, excuse me, but I will go ahead and go over the algebraic methods of basically the rules and how to solve problems using composition of functions and also function operations. So let's go ahead and get started. So the first thing I want to say is basically if given two functions, and I want to say, for example, and I'm actually going to zoom in here so that y'all can see it better. Let's do if given two functions, and let's do f. So let's do over here. Let's say we have two functions. One of them, let me actually do. I want to do a different, like a, what is it, like a different, how do I do this? Sorry guys, 1 second. I don't know why it's, okay. Let me do, so if I'm given two functions, let's say, for example, I'm gonna do, one second guys. Let's say there's f, so f of x, and g of x, right? So if I have two functions like this, basically what we're gonna go ahead and do is I'm gonna write down the rule. So g of x, and then let the following be true. So we can say the following. So basically the idea is that or actually let's do it this way. Hold on guys. Let me do it in block first. So basically f, and then plus g of x. So plus g and of x is equal to the following. It's going to be f of x, f of x, and then it'll be, let me do again, plus g of x. So that is kind of the idea that I want to put out there. So basically, this rule can be, you know, it can be, and this is the addition of two functions, by the way. So we can add, subtract, multiply, and divide just like we would with numbers. So that's kind of what I wanted to put there. Give me a second, guys. I'm gonna, I don't know where I put my pen at. 1 second, guys. Give me 1 second. Okay, sorry about that, guys. Okay, so we know that this is true for this following rule here. And basically, this is, like I said, this is called, and I want to kind of put a little arrow here. Let me actually, sorry if I'm a little bit slow, guys. I'm like trying to like make sure. This is the addition of two functions, f of x and g of x. So that is the idea of basically of what this means. We can do an example, so I'm going to go ahead and actually start writing on here. So basically, let me go ahead and we can go ahead and do an example here. So so basically, if I just zoom in here, if I have, for example, and this is going to be an example, oops, sorry guys, 1 second. And what we're going to do is we are going to go ahead and we're going to go ahead and do, so let's say, for example, we have f of x is equal to, so f of x is equal to, and we have, let's say, for example, 2x squared plus 3x minus 6, right? And I go ahead and say the following. So, and I also have some other one. Actually, my bad. Let me do it in pink and red. If I'm a little bit slow, guys, I do apologize. Usually on videos, I usually edit this out, or I you know, put this out of the way. Give me a second, guys. I don't know why it's doing that right now. Give me 1 second, guys. Okay. So like I said, f of x, let's say for example, f of x is going to be 2x squared plus 3x minus 6. Okay. And let's say that g of x, so g of x is equal to the following. So we can say that this is going to be, I don't know, like 7x squared plus 5x minus 2. And then, you know, so given the two functions, f of x equals this and g of x equals that, find, and we're going to do let's do f plus g of x. Okay, so then basically the rule applies, right? We're going to go ahead and we know that the following is true. This is equal to f. So again, if I just grab this, I'm going to just go ahead and copy this, and then I'll paste it right over here. And the rule is, again, as follows. So the rule is basically going to be that it's going to be f of x plus g of x. And a lot of people, guys, confuse this with distributive property. They're not being multiplied, they're being added, but it's like an addition of two functions. So I really want to make sure that we don't confuse that. So yeah. So now what we're going to do here is we are going to go ahead and actually, 1 second, guys, just to make sure everything is running smoothly. Okay. So basically, using this rule, we know that f of x is 2x squared, so 2x squared plus 3x minus 6. And we know that g of x, so plus g of x is like, what was it? It was 7x squared plus 5x minus 2. Oops, plus 5x minus 2. And I always like to put per. Basically, you can kind of clearly see what I'm doing here. And so this ends up being, and what we can do actually is we can just write this as 2x squared plus 3x minus 6 plus 7x squared plus 5x minus 2. And so from here, we can go ahead and combine my like terms. So we can combine our like terms using algebra. So we have a 2 and a 7. We also have a 3x and a 5x. So 2x squared, 7x squared, 3x, 5x. And then we also have a -6 and a -2. So really this becomes 2x squared plus 7x squared plus 3x plus 5x minus 8, or I'm sorry, minus 6 minus 2. So again, I'm just going to get in here and kind of show you guys very clearly what I'm doing. In my videos, guys, I like to be very clear. Maybe I'm, I guess, OCD, but I try to be as clear as I can in case, you know, so that people can really see what I'm doing. Because some of the stuff, I know for me, I'm a visual person, so, and math is very visual, so I like to really put down all the steps. So then we know that this becomes 9x squared, so we have that. 2x squared plus 7x squared, that's 9x squared, and then plus, and then 3x plus 5x, that's just 8x. So again, we'll just go ahead and put this in here, and then minus 6 minus 2, so basically we would put right here, it would be minus 8 for over here, so minus 8, and that would be, basically this would be the answer for this problem. So this means that we can clearly say now that f plus g of x, so thus f plus g of x is equal to 9x squared plus 8x minus 8. Now, there is one thing I want to mention, guys, and that is the idea that that about commutative properties. So basically, there's a certain rule, and I'm gonna go ahead and write it down or type it here. So the rule, basically what I wanted to put is that we can also apply commutative property, to the addition of two functions. I do want to mention you cannot do this with subtraction, but we'll get to that in a minute. So what I mean is commutative property goes as follows. If you have two numbers, a plus b, so if basically it goes a plus b is equal to b plus a, right? And so from here, I'm just gonna write it down in pen so that you guys can see. I like to color code a lot, so I'm gonna write it down in pen. So basically it goes a plus b is equal to b plus a, so b plus a. You cannot do this with subtraction, so that's the main idea I want to put out there, is that you cannot do this with subtraction. You can do it with addition, though. So basically, if we go ahead and do this, we can clearly say that, you know, the idea is as follows. So if we apply this to the composition of functions, we can clearly say that the following is true. So by, and let me actually type it. So similarly, we can apply this rule to the addition of two functions. And the rule is, by commutative property, the following, by commutative property of addition, the following must be true, can be true, can be said about, and I'm gonna write, let's just do, let me go over here really quick and just go to home and then do, so basically, and actually I'm gonna put here first, I'm gonna put this about f of x and g of x. So actually I'm gonna put about f plus g of x, because what I'm trying to say here, guys, is we can apply commutative property to this. And if y'all don't know what commutative property is, I just wrote the rule down. It just means that you can do that with addition of two functions, or addition of two things. So it can be about f and then plus and then g, so g and then of x, right? So basically this is the following thing that I'm going to write down here. So I want to say it's going to be, it's going to be the following. And actually, let me go over here. And I'm going to put f, and again, plus, and we have g. We have g here. Sorry, guys, give me a second. Oh, gosh. Plus g, and then of x, so is equal to g is equal to, and actually, let me put first g plus f of x. So, basically, this stuff here. So g plus f of x, right? And that's the rule that I want to make very clear. I feel like it's better if I write it down, but my handwriting kind of sucks. Oops. Sorry, guys. I'll write it down after this because I feel like it takes too long to. Okay. So this can be true, right? Because they're being added, and when they're being added, we can use commutative property. Just like if we say 2 plus 3 is equal to 3 plus 2. So it's like, for example, I'm going to go over an example. Let's say that f of x, so let's do f of x is equal to 3x minus 6, and g of x is equal to x plus 4. And then I want to say, verify that f plus g of x is equal to g plus f of x, excuse me, g plus f of x. So basically, if we do f plus g of x, we have f of x plus g of x. So that's what this is here, this whole thing. And then this should be equal to g of x plus f of x. So that's just a rule, guys. And I can prove that to y'all algebraically. Or numerically, but I would say algebraically more. So this would be the following. So we would have 3x minus 6, and then sorry guys, give me a second. Understand why it's doing that. Okay, we would have 3x minus 6, and then plus, and then g of x is x plus 4, so x plus 4. So again, this is this part, is equal to g of x, so g of x, which is x plus 4, and then plus, so like this, and then f of x, which is equal to 3x minus 6. Give me a second, guys. I'm gonna go ahead and lower the... Okay, so give me 1 second, guys. I'm gonna just go over here and So, all right, so using this rule, so we have x plus 4 and then plus, and it will be 3x minus 6. So again, we can clearly see that they're the same thing. So we can say 3x plus x minus 6 plus 4 is equal to x plus 3x plus 4 minus 6. This is the exact same thing. This is equal to 4x, negative 6 plus 4 is minus 2, and then this is equal to 4x, and 4 minus 6 is negative 2. So we have proven that, obviously, it works this way. Okay, guys? So I just wanted to make that very clear. So that's how we know that commutative property plays a huge role in this in addition of between two functions. Now we're going to get to subtraction of two functions. So the thing with subtraction of two functions, guys, is that it's a little bit different than actually than actually it's a little different than addition of two functions. So subtraction of two functions, let's just kind of, I'm going to write down the actual rule, and I'm going to do, let me go ahead and do go ahead and go over here. So basically what I wanted to say here is that if given, so if given f of x, if given two functions, so if given two functions, let's say f of x, let's say f of x and g of x, right? So I'm gonna do f of x and g of x. So here we have, let's do f of x and g of x. Then we can say the following. And so here, what I wanted to say was that basically the following is true. So we're going to go ahead and actually write the following down. So f plus g of x is equal to, I'm sorry, excuse me, minus g of x, sorry, minus g of x minus g of x is equal to f of x minus g of x. So we would kind of go ahead and put that in there. So one second, guys. So how we're going to do this is we're going to go ahead And actually, 1 second, guys. Okay. So we're going to go ahead and say the following. This is f of x minus g of x. So then we know that this is the the subtraction of two functions. One thing to notice, guys, and what I want to kind of show you, and we're going to go over an example. Example. And the example that I want to go over is the following. And give me 1 second, guys. So give me a second, guys. I'm sorry. Hold on. Okay. One second, guys. Sorry. I'm making sure that the... Okay. Let me put... Sorry. 1 second. Okay. So what I was saying was, we're going to go ahead and, for example, if we have f of x is equal to 2x cubed minus 3x squared plus 4x minus 1, and we say g of x is equal to 5x cubed minus 6x squared plus 9x minus 7 as an example. What we're going to do here is we're going to go ahead and we're going to go ahead and do f minus g of x. So let's do that. F minus g of x. And so this means we have, again, f of x minus g of x. So basically, it's going to be equal to, and we're going to do 2x cubed, 2x cubed minus 3x squared plus 4x minus 1, and put this in parentheses, of course. So we're going to put that in parentheses. Let's see. So put this in parentheses, and then minus, and then we're going to do g of x. But one thing to note, guys, is that you have to put it in parentheses. Otherwise, it's going to be wrong if you don't put parentheses, because we have to distribute that negative. It's very important that we do that. So then we can take off the parentheses for this one. So we have 2x cubed minus 3x squared plus 4x minus 7. I'm sorry, minus 1. Excuse me. And then from here, we can go ahead and say, we can go ahead and say the following. So, one second, guys. Just gonna... Okay. So, let's see. We can distribute the negative in here. So we're going to do minus 5x cubed. And actually, like I said, we can take off the parentheses for this one. But we're going to do minus 5x squared, cubed, plus 6x squared, minus 9x, plus 7. So just note that the negative distributes there. And that's why it's like that, basically. So let's see here. So we're gonna go ahead and actually, one second, guys. Give me just a second. Sorry, I keep pausing. Let me go over here. Give me 1 second, everybody. I'm gonna try to go off, like turn the screen off for a second. I just want to put this. Give me a second, everybody. Give me 1 second, guys. I'm sorry. Okay. So, where were we? Okay, so let's go ahead and go back to the problem that we were in. So, let's see. So, here we now have, this. So basically, we're going to go ahead and combine our like terms. So we're just going to do this here. 2x cubed minus 5x cubed. And we're also going to do 6x squared minus 5x, minus 3x squared. So we're just basically going over and combining our like terms, right? So that's kind of what you do after you distribute all this stuff here. And then finally, it would kind of be this one and this one. So if we write all this stuff down in order, so it's going to be 2x cubed minus 5x cubed minus 3x squared plus 6x squared plus 4x minus 9x minus 1 plus 7. So we're gonna go ahead and just put this in here. So give me a second, guys. I'm gonna connect my charger. 1 second, everybody. I apologize. Okay. So yes, as I was saying, we would go ahead and do this, right? And basically, from here, we're gonna go ahead and combine our like terms. So we have, sorry guys, 1 second. It's gonna be negative 3x cubed, right? So that's what we have here. And then negative 3x squared plus 6x squared, so that'll be I'm sorry, guys. I'm sorry, guys. It's having technical difficulties. Oh my goodness gracious. Okay. So again, we would have the following: negative 3x squared plus 6x squared, and then one second, guys. 1 second. Okay. Hopefully this will work now. So as I was saying, we have that, and then we have the 4x minus 9x, so that'll be this one here. And then finally we have the negative 1 and the 7. So this is how that's done. So then this will be, like I said, this part is going to be plus 3x squared, and then 4x minus 9x, that's going to be minus 5x, and then negative 1 plus 7 is going to be plus 6. So this would be our final answer for this problem, guys. So that is how we do this problem. I don't know why. I'm so sorry, guys. My analytics are just being, I don't know why it's having issues. I'm gonna turn on slow mode again. I don't know why it just does that for some unknown reason. Let me see. Okay. I'm hoping it's not as bad now. I don't know why it's doing that. For some reason it says my stream is like just not running well. But anyways, we're gonna move on. Another thing that I want to go over, so if I do the same thing, let's say for example we now have g of x, so g of x or let me just explain. So g minus f of x we can also say is g of x minus f of x, and we're going to do the same example we did, but now g of x is going to go first, and then it'll be f of x. So in this particular part, we now have the following. Give me a second, guys. So we now have the following stuff, and so now we can go ahead and say, so g of x we had said was 5x cubed minus 6x squared plus 9x minus 7, so right, and it goes like this, and then minus f of x, so minus f of x is going to be the following, so it's going to be minus parentheses, and f of x was 2x cubed minus 3x squared plus 4x minus 1. So if we do that, we have minus and then parentheses. I'm sorry, guys. Oh my goodness gracious. I don't understand why it's having issues. I do want to apologize, guys. It's not supposed to be doing this. Let's do this. And then, okay. Somehow it's healthy again. I guess, I don't know, it's weird. It's very strange. Okay, so, like I was saying previously, and let me actually... Okay, I'm gonna just do that. And let me do this here. So g of x plus, I'm sorry, g of x minus f of x. We're going to go ahead and apply the rule. And there's something in particular that I want to show you guys here. So in this particular part, let me actually go over here, zoom in. Basically, we have g of x minus f of x. And so the way that's going to go is we're going to put f of x, and f of x was 2x cubed minus 3x squared plus 4x minus 1. So 2x cubed minus 3x squared plus 4x minus 1. And so this is going to be the following. So we're going to have the following. So it'll be it will be, so it's basically, we take the parentheses off of here, 5x cubed minus 6x squared plus 9x minus 7, and then we're going to go ahead and distribute that negative again, so like this. And so if we do that, we're going to have minus 2x cubed plus 3x squared. So anytime it's a negative of a negative, it's positive, and positive of negative, positive times negative is negative. Just want to make that very clear. And then minus 4x plus 1. So then we combine our like terms again, right? We have 5x cubed, negative 2x cubed. We also have negative 6x squared, 3x squared. We also have 9x, negative 4x. We also have negative 7 and positive 1. So then we have 2x cubed minus, 5x cubed minus 2x cubed. That's going to be 3x cubed. So we're going to do 3x cubed, and then negative 6x squared plus 3x squared, that's going to be minus 3x squared. So again, I'm just going to get in here and show you guys what I'm doing. So this is this, and then this is this over here. And so 9x minus 4x, that's going to be plus 5x. So again, we have this, and then negative 7, so we already did that. And then negative 7 plus 1 minus 7 plus 1. That's that part. So it's this part here, and we know that negative 7 plus 1 is negative 6. So I know that that's what this is here. And so we can basically cross all of these out because we've already simplified it enough. So our answer becomes 3x cubed minus 3x squared plus 5x minus 6. So that's how we know f minus g of x, or g minus f of x is that. Now notice one particular thing, guys. So obviously we have two different things. So for f minus g of x, so I want to make this very clear. So when we said f minus g of x, what we got for that was this following thing. So it was negative 3x cubed minus, or plus 3x squared. So it was negative 3x cubed, and then what else? I'm sorry, hold on, guys. Plus 3x squared minus 5x plus 6. And then for g minus f of x, we got 3x cubed minus 3x squared plus 5x minus 6. So basically, we can clearly see that f minus g of x, so thus the following must be true. And that is the idea that f minus g of x does not equal g. minus f of x. And that's the idea that I wanted to make very clear. So we cannot, so therefore, we cannot use commutative property. Sorry for my handwriting, guys. Let me try to write it better. So therefore, we cannot use commutative property, or we can, basically, commutative property does not apply for subtraction of two functions. So it's like I said, f minus g of x does not equal g minus f of x. And that's the idea that I wanted to make very clear. So now what I want to do is go on to the product of two functions. So product of two functions. So basically, this does apply with, I think it is commutative property, if I'm, because I know commutative property also applies for, give me a second, guys. Okay, yes. So now commutative property does apply for product of two functions. So again, commutative property of multiplication. This means that if we have a times b, this is the same as saying b times a. Okay, and so we can use that idea, or that theorem, right, to do this. Now, so commutative property can be applied when multiplying two functions. So basically, if f of x and g of x are multiplied, then the following theorem is true. And we can say that f g, so basically the way they say it is f g of x is equal to f of x times g of x. So we know that this is true. And so, and we also know that the same is true for the other stuff as well. G times f of x, g f of x is equal to g of x times f of x. So we can use that idea for commutative property. Okay, guys. So now we have this following kind of theorem that holds true. So doing some examples. if I have a function, so if I have f of x is equal to, let's say, x minus 4, and g of x, let's say, is 2x squared minus 5x plus 6, and then, so given the two functions f of x equals x minus 4 and g of x equals 2x squared minus 5x plus 6, find f times g of x. So again, we know that this rule, f times g of x, is equal to f of x times g of x, okay? So sorry guys, 1 second. I don't know why it started doing that. So we know that following theorem holds true, right? So let's see here. So now we know that basically f times g of x, like I said, was f of x times g of x, right? So like this, and then from here, we're gonna do, let's see here, x minus 4, so we have x minus 4 times the quantity 2x squared minus 5x plus 6. Okay, and so here we would do basically FOIL method with this. So we have x times 2x squared plus x times negative 5x, basically. So let's do it this way, actually, guys. Hold on. So we have x times 2x squared plus x times negative 5x plus x times 6, and then minus 4 times 2x squared. And actually, let me zoom in. My bad. And then minus 4 times negative 5x, and then minus 4 times 6. So now let's go ahead and simplify this. X times 2x squared, that's going to be 2x cubed, right? So then, and then we have x times negative 5x, that's going to be minus 5x squared. And then x times 6, excuse me, it's going to be plus 6x. And then negative 4 times 2x squared is negative 8x squared. Negative 4 times negative 5x is plus 20x. Plus 20x. Negative 4 times negative 5x. And then negative 4 times 6 is minus 24. So now we're going to combine our like terms. So let's do that. So we have negative 5x squared, negative 8x squared. We also have 6x, 20x, and then we have, I believe that's it for that. pretty sure. Okay, I think that's pretty much all the ones that, I mean, we also have the other two, which were like 2x cubed and negative 24, but those are not, I mean, we don't have to, those are by themselves. We're not going to, like, how do I say it? We're not going to do anything with that by any means. So we end up getting 2x cubed, and then negative 5x squared minus 8x squared is negative 13x squared. 6x and 20x, that's plus 26x. And then we're just going to be left with minus 24 like this. Okay, and that is how you do the multiplication of two functions, the product of two functions, right? Okay, and now the last, well, one of the last things, we're almost done. Basically, I want to go over the idea of doing, how do I say, of doing the division or the quotient of two functions. Now this one is different. So obviously one of the things about these is that we have to understand that so if given f of x and g of x when dividing the following must be true. So we're going to do f over g of x is equal to f of x over g of x. Oops, sorry guys, 1 second. But this is true such that g of x cannot equal to 0. Sorry guys. So let's do some examples. And also another thing I want to make clear is that one important note is that f over g of x does not equal to g over f of x. Sorry guys, 1 second. Over f of x. Okay. So, and also I want to make clear as well, g over f of x over f of x is equal to g of x over f of x, such that f of x is not equal to 0. So basically, I'm going to give some examples here. So if I say f over g I'm sorry, excuse me. So I want to say, for example, f of x is equal to x minus 2, and g of x is equal to 3x minus 7. And so I say find the following. So I want to do f over g of x of x and g over f of x. Okay, so the one thing that I want to go with here, and the one thing I want to try to show you guys is that these are not equal to each other. So I'm going to go ahead and show y'all what I mean. So let's do first f over g of x. I know, again, f of x is equal to x minus 2, and g of x, like we said, was 3x minus 7. So we know for this one, I'm going to do f over g of x, like I said, it was equal to f of x over g of x, right? And so this is going to actually be x minus 2 over, it's going to be 3x minus 7. Okay. And so we know that from this, we have, you know, this is basically what we end up with. And also, let's see here. Also, I want to make sure we understand that a over b does not equal b over a. If a squared does not equal b squared. Basically, if I say 2/3 is equal to 3/2, that's going to be wrong. 9 does not equal to 4. So that's the idea that I want to make very clear, guys. That's why we can't use the rule that, that's why there's the rule that f over g does not equal g over f. So if I find g over f, so now let's do g over f of x. So if I do that, I have g over f of x, and that's going to be the following. So it's going to be, let's see here, 3x minus 7. So again, we put g of x over f of x, word, or f. And so doing this, we end up with 3x minus 7 over x minus 2. And like I said, guys, if I have these two things, let's say I want to know if 3x minus 7 over x minus 2 is equal to x minus 2 over 3x minus 7. If I plug 1 in here, let's do x equals 1. I'm going to have 3 times 1 minus 7 over 1 minus 2 is equal to 1 minus 2 over 3 times 1 minus 7. numerically, this is not going to work. They're not going to be equal. So basically, watch how it goes. We're going to have 3 times 1 is 3 minus 7. So this is what this is. Over 1 minus 2, that's negative 1. And then this stuff is then equal to negative 1 over 3 minus 7. So this is going to be negative 4 over negative 1 is equal to negative 1 over negative 4. Obviously, 4 does not equal to 1/4. This cannot work, and that's why we cannot say that f over g equals g over f, because when we evaluate a specific value here, it is not going to, it's not going to work. So we've kind of proven algebraically how that works, or numerically how that works. One last thing I want to go over is the idea of composition of functions, and this is going to be the last part of this live stream. A lot of this has been mostly doing it algebraically without actually evaluating. I'm gonna, for composition of functions, basically, let me just kind of do, actually, let me do a numerical function arithmetic. So I'll do this really quick. So if I have f of x equals 3x minus 1 and g of x equals 4x plus 2, I want to find the following: f plus g of 1, g plus, I'm sorry, no, excuse me, f minus g of 1, g minus f of 1, f g of 1, f over g of 1, and g over f of 1. And what I'm going to do here, I'm going to make this this color, and I'm also going to make this color, and we're going to go ahead and just kind of color code here. So f plus g of 1, f minus g of 1. So I'm just kind of color coding for you guys so that y'all know what I'm doing. F minus g of 1, g, let me write it down, guys, sorry. Let's do g minus f of 1 fg of 1, so fg of 1, fg of 1, f over g of 1, and g over f of 1. So, like I said, I'm just kind of writing down this stuff and color coding it so that you guys know what I'm doing. And we're just going to do one example of these like that, and then finally we're going to get into composition of functions, and that'll be it for this live stream. So, for example, we have, again, we have f of x equals 3x minus 1, and g of x is equal to 4x plus 2. So we have f plus g of 1 is equal to the following: f of 1 plus g of 1. Sorry guys, 1 second. I'll be right back. Okay, sorry about that, guys. I do apologize. Alright, so, let's see here. Let me go ahead and turn this off. Let's go back to what we were doing on here. Oh, and my bad, I literally forgot to, change the, sorry guys, 1 second. I forgot to change the, there we go. Okay. Alright, so then what we have here, so we have plus g of 1. Oops, sorry. So we have the following, and we're gonna, let me go ahead and do full, let me do full video here. So we have this, right? And it's like that. And so we know that f of 1, if we do f of 1 of the following, it's going to equal to 3 times 1, and then close parentheses minus 1. So then it will be 3 minus 1, which is 2. So we know that that's going to be 2. And then g of 1 is actually going to be it's going to be equal to the following. So we have the following here. We're going to do sorry guys, 1 second. Let me do this actually. Okay. So okay, sorry about that, guys. So g of 1, like I said, is going to be the following, and we're going to do let's see here. It's going to be 4 times 1, close parentheses, and then plus 2. So then this will be 4 plus 2, which is 6. So now we know that this part is 6, and we're, you know, that's g of 1. G of 1 is 6, and so then we have 2 plus 6 here. It's going to be 8. So we know that f plus g of 1 is 8, because it's 2 plus 6, and it's 8. And now let's do f minus g of 1. So we're going to do, so again, we don't have to keep going with the same, we know what f of 1 is, so basically we're going to do f minus g of 1. F minus g of 1. That's f of 1, f of 1. Oops, f of 1. Actually, hold on, guys. F of 1 minus g of 1. So, like this. And then we're going to go ahead and do that. So, we have f of 1. F of 1 is like, well, we know what f of 1 is. It was 2. We know f of 1 was 2 because we evaluated it earlier. And then minus g of 1. G of 1 was 6. So it'll be 2 minus 6. And 2 minus 6 is going to be negative 4. So we know f minus g of 1 is negative 4. And now let's do f over g. I'm sorry, f times g of 1. So, actually, I'm sorry, g minus f of 1. So now let's do g minus f of 1. That's equal to, it's going to be, like I said, g of 1. And then minus f of 1. So it'll be like this, right? And so if we do that, g of 1, like I said, g of 1 was 6, so we know that that's going to be 6 because we already evaluated it. So once you evaluate it, guys, you don't have to do it again over and over because we already did it in the previous problems. And then, so then it's going to be minus f of 1, which was, I'm sorry, I think it was 2, right? Yeah, 2. So 6 minus 2 is 4. So we know that f, or g minus f of 1 is 4, right? Sorry, guys. And then let's do f times g of 1. So now we're going to do f g of 1 okay, and so this is going to be f of 1 times g of 1. So okay, and so with this we know f of 1, like I said, it was 2, so we know it's going to be 2, and then times g of 1. G of 1 was 6. So again, g of 1 was 6. Okay, and so we have 2 times 6, and we know that 2 times 6 is going to be 12. So it's 12 right here. So we know that fg of 1 is 12. Right, guys? And then if we look at give me a second, guys. If we look at f over g of 1, so now we're going to do f over g of 1, right? So we have f over g of 1. This is f of 1. It's going to be f of 1 over g of 1. So it's like this. And so we're going to go ahead and actually put, so f of 1, like I said, it was 2. So we have 2 over g of 1, which was 6. So 2 over 6 divided by 2 on top and bottom, we get 1/3, excuse me. So we know that f over g of 1, f over g of 1 is equal to 1/3. So that is how we do that one. And then we're going to go ahead and do g over f of 1. So g over f of 1. So again, this is going to be g of 1 over f of 1. So it's like this. And then finally, we're going to do So g of 1 is 6, like I said, it was 6. And then f of 1 was 2. So 6 divided by 2, and so we get 3. So we know that g over f of 1 is 3. Okay, guys, the last thing that I want to go over in this video or in this live stream is composition of functions algebraically. So so if we have two functions, f of x, if given two functions, let's say f of x, let's do actually f of x and g of x, then the following must be true. So we know it's going to be f composited of g of x is equal to f of g of x. And g composited of f of x is equal to g bracket f of x. So like this, right? And this is how basically there's a difference between these two guys. And so what I want to also make very clear is that, well, basically, a note that f composited of g of x is not equal to g composited of f of x. The way we say this is g composited of f of x of, sorry guys, I can't write today. Okay, or g composed of f of x. Okay, so I just want to make that very clear, and also we're gonna go ahead and do we're gonna go ahead. Give me 1 second, guys. Hold on. Okay, sorry about that, guys. We're gonna go ahead and say So, where was I? G composed of f of x. So these two are not equal. And so we're going to do an example. We're going to do some examples. So if I have, for example, f of x is equal to 2x minus 3 and g of x is equal to x squared minus 2, I want to find the following: f composited of g of x and g composited of f of x. So I know that for f composited of g of x, for this part, we're literally going to say f bracket g of x right? And so I know g of x is x squared minus 2, so really this is going to equal to f of x squared minus 2. And so I know that my function f is the following. It's basically going to be, hold on guys, it's basically going to be 2, and then it's going to be 2, and then we're going to plug in x squared minus 2 in for x. So it's going to be 2 times the quantity sorry guys, 1 second, times the quantity x squared minus 2, and then close parentheses, and minus 3, so like this. And lastly, what we do is we distribute in the 2x squared, the 2 times x squared minus 2, and we end up getting 2x squared minus 4 minus 3, just 2x squared minus 7. And we know that f composited of g of x is thus 2x squared minus 7. Now if we do g composited of f, g composed of f of x is equal to, and it's going to be, let's see here, it's going to be g bracket, actually it's going to be g bracket, so g of, literally g of f of x. So in other words, we know that g of x is going to be, and actually this is supposed to be like that. I don't think we have to color code. We have to put it in black there. So basically we're going to put in f of x into g of x for x. So our original function is g of x is equal to, and it was, what was it, 2x minus 3? Or actually, wait, x squared minus 2. But, so g of f of x is going to equal to f of x quantity squared minus 2. And f of x squared, well, we know f of x was 2x minus 3, I think. Yeah. So this is going to go in for this here. So therefore, so thus, it's going to be G composited, G of f of x, G of f of x, is equal to, it's going to be the quantity 2x minus 3 quantity squared minus 2. So, doing this, we know that we can use FOIL method, 2x minus 3 times 2x minus 3, or you can use the sum and difference pattern, a plus, or the sum of two squares pattern. A plus b quantity squared is a squared plus 2ab plus b squared. If we do that, we end up with 2x squared plus 2, I'm sorry, excuse me, it's supposed to be, I'm sorry, minus b quantity squared, a squared minus 2ab plus b squared. I'm sorry, guys. So it's going to be 2x quantity squared minus 2 times 2x times 3 plus 3 squared. I mean, if you guys don't understand that, I'm just gonna quickly, like, do this really quick. Just so y'all can kind of get an idea of what I am doing here. It's like that, basically. Okay. So then this becomes 4x squared minus 4x times 3 plus 9. And then finally we get 4x squared minus 12x plus 9. And that's what that part is. So this part is 4x squared minus 12x plus 9. We're not done yet, though. We need to subtract this 2 in there. So subtracting 2, we get 4x squared minus 12x plus 7. And this is going to be our answer for f of g of x. Actually, wait. I'm sorry, g of f of x. Excuse me. So g of f of x is going to equal this stuff here. Okay, guys. And so, when you're doing, basically, one last thing, when you're evaluating a composition of functions, f, let's say for example, and this is going to be probably the last example I go over, f of x equals 2x squared plus 9x minus 15, or let's do minus 8, and then g of x is equal to x minus 2, and I want to find f composited, I'm sorry, I want to find the following, and I'm going to put f composited of g of 1. So find f composited of g of 1 and g composited of f of 1. Okay, so we're going to do, so basically this means here, we're basically going to do this exact same thing. We can say f composited, so basically this whole stuff here, let me just go ahead and write it down. F composited of g of 1 is equal to f bracket of g of 1, so g of 1. Now, the way this works, we need to first go what's on the, know what's on the very inside. This is the inner function. So we need to understand the difference between those two things, or how that works, basically. So, give me a second, guys. I'm sorry. I have to plug it back in because it's gonna die on me. Okay. So we know that this is gonna be the following. So we first do g of 1, right? And we know g of x is x minus 2. And so we know g of 1 will be 1 minus 2, which is going to be negative 1. This is g of 1. So now we're going to put this in for this up here. So f of g of 1 is really f of negative 1. So it's going to be negative 1 here. And then finally we're going to do f of negative 1. Well, f of negative 1 is going to be 2 parentheses, and we're just plugging it in for x here. So 2 times negative 1 quantity squared plus 9. So maybe be careful with that. Plus 9 times negative 1. And then minus 8, I think, here. So this is 2 times 1 minus 9 minus 8, which is 2 minus 17, which is negative 15. So I know that f of g of 1 is negative 15, so thus f composited of g of 1 is negative 15. And we can say that. Now, let's see here. So now we're going to do g of f of 1, right? So g composited of f of 1. So this is g bracket. Let's do it like this, actually. Bracket g of f of 1. So now we need to first know what f of 1 is, and then do g of 1, or g of whatever that is, right? So, we have f of 1, so f of 1 we know is going to be, let's see here. Let's see here. So g of f of 1 is going to be the following. And I'm going to do, so f of 1, we know that's going to be 2 times, and it's going to be 1 squared, so 2 times 1 squared, 1 quantity squared. And it's going to be plus 9 times 1. One second, guys. Plus 9 times 1. And then it was minus, I think it was, what was it? Minus 8. So then this is going to be 2, because 2 times 1 squared, 2 times 1 is 2. Plus 9 minus 8. 11 minus 8, which is going to be 3. So we know that f of 1 is 3. And now we're going to plug this in to g of f of 1 for that. So now we're going to plug this in to here, right? And so that'll give us the following. We're going to do, so now g of f of 1, so it's going to be, so I know that g of f of 1 is now going to be equal to g of 3. So let's do g of 3, right? Because that was what we got for f of 1. I'm sorry, yeah, f of 1. So now that equals g of 3, and now we're going to use the other function, which was, what was it? X minus 2. So it's going to be 3 minus 2, which is equal to 1. So I know that g of f of 1, so thus g composited of f of 1 is equal to 2. I'm sorry, is equal to 1, excuse me. Okay, guys, I think I'm going to end it here because it's already, I don't know why, it's like lagging. But I do hope that helped. I know that during the stream I was very, it was a little bit hard to, because I kept pausing, but I really hope that helped. And with that being said, guys, thank you so much for watching. Whoever watches this stream, thank you so much. And also, please support me. Please subscribe if you can. And thank you so much for watching, and I'll see you guys next time. Bye, guys.